In this video, we're going to introduce the concept of inversion of control and also see how it's used in Spring. When we use a main method, we're not inverting control because the main method is in control of the entire application. It will call other methods, and those methods will then return values that the main method can work with. For example, we might have a menu library, and the main method will call methods in that library that will trigger the display of a list of available commands and then ask the user to select one. The library would return the chosen option, and the main method would then use that to execute the associated command. With inversion of control, we're no longer making use of a main method. A software framework will provide that common functionality and is in control of how the application behaves. The programmer will write custom code that will fill in the blanks for the framework. So it might well be that we've got a table of menu items, and each of those items has got a callback method. And then the framework will monitor the user's actions, and when the user selects a particular menu item, the framework will then invoke the callback method that is associated with that menu item. And so the framework is in control, not the programmer's application code. And thus we have the concept of inversion of control. In Spring, there is an inversion of control container whose job is to manage the creation, deployment, and deletion of objects. The objects that are created by the IOC container are registered in the application context, and we'll see more about that in a few moments. These objects are then available for use elsewhere in the application. So if we need an object, we could do one of two things. We could create that instance ourselves and then use it and then take whatever steps are necessary to delete it, or we could get an instance of it from the inversion of control container. The IOC container will need to be told what objects it should manage, and we can do this with source code annotations. The Spring framework will detect objects that it should manage by scanning the class path, looking for annotations, some of which we're already familiar with: at controller, or rest controller, or service, or repository, and some that we haven't seen yet: at configuration, component, and bean. All of these annotations indicate that there is a class or a section of code that will generate an object that is to be managed by the Spring framework. The application context is a central interface that will provide configuration for an application. For example, it will provide factory methods for accessing application components. Using inversion of control, Spring collects components from our application, stores them in the application context, and uses them when needed. If we've got a class that is annotated with @component, then Spring will inject any specified dependencies. So if that object has got references to other managed objects, references to those managed objects will be stored in that object. And then it will store that instance in the application context and then use it whenever it's needed. Now, this has been happening with controllers and REST controllers and services and repositories that we have used in our applications so far. And because these are specializations of component, these objects don't have to be created by us because they are managed by the IOC container. Instead of having an entire class annotated as a component, we might just want to have one method that will generate an object that can then be managed by the IOC container. And that's the purpose of the @bean annotation. So we would put this annotation in front of a method, and it will tell Spring that it should use this method to generate an object that it then stores and manage its lifetime. Usually, these methods that are annotated as producing beans will be in a class that is annotated as a configuration class. We've got one of those in our application automatically, and that's the Spring Boot application. But we could also annotate a separate class as @configuration and make sure that it is in the same package or sub-package as the main application class. When we want to inject a bean, what we would do is have our method that is going to produce a result of a certain type and then annotate that method as being a bean. When the IOC container performs dependency injection, and in the next video we'll talk a bit more about this dependency injection, the IOC container is going to look for a method whose name matches the variable that is being managed by the IOC container. So down here we've got a private final variable of type string programmer name. And the IOC container will then look for a bean method that returns a string and is called programmer name. So these two must match. And that's all that we need to do to generate a bean and have it automatically inserted as the value for our variable. Occasionally, and it should be as infrequently as possible, it might be necessary to look up a bean explicitly rather than to have the IOC container take care of all of it in the background. Typically, this would be done for local variables in a method, and for us to be able to access those beans explicitly, we would need to inject the application context like this. So we would have a private, typically final, application context. That's the name of the variable. And as long as we've annotated the class with the all_args constructor, that will tell the IOC container to insert a reference in here. Then down in the method that's going to use a local variable, we can get hold of the bean from the context by putting in the name of the bean, which is the name of that method there. The context will return a reference to that bean, and we can store it in our local variable and make use of it. Sometimes we will need to tell the IOC container just how long to keep a bean in existence. And this is the scope of the bean. There are the values. So if we say that the scope of a bean is singleton, then the IOC container will create just one instance and return that instance every time it is needed. If it is a prototype scope, a different instance will be created every time a request is made for that bean. If the scope is request, then one instance will be used for a single HTTP request. Similarly, for session, one instance will be used every time it is needed in a given session. Remember, a session will begin with the first request from a given client, and then all subsequent requests from that same client will be part of the session. Application scope similar to singleton, in as much as it is used for the entire application. And then you have WebSocket as well, that will create an instance of that bean for use in a single WebSocket session. So those are the bean scopes. And if we want to set the scope of a given bean, then after the @bean annotation, we can then put in a scope annotation with the selected value, and that's it. Spring will manage the rest. You'll probably need to do some additional background reading about some of the terms that we've introduced in this video. Inversion of control is a very important concept, so you should look at this in a bit more detail. And you might also want to take a look at the bean annotation in a bit more detail too.